Hi, I'm Kenneth. I'm going to talk a little bit about foam radiation absorption. This graph shows like how the human body absorbs the radiation in a simple term. When you speak into the phone will convert your voice into a form with signal and broadcast that signal in all directions in the attempt to reach the nearest base station. Most of the energy is lost. Some of the energy is received by the base station, and the group portion of the energy is absorbed by the body. We have a unit of measurement known as specific absorption rate to describe such incident. Specific absorption rate, abbreviated as SAR, is a measure rate at which the energy is absorbed by the body when exposed to a radio frequency electromagnetic field between 100 kHz and 10 GHz. It is defined as the power absorbed per tissue per mass of tissue in unit watts per kilogram. Since the SAR depends on many factors like geometry of body part that is exposed to RF energy, the exact location of the RF energy source, the variance in SAR level between different transmission bands, and the model of foam. So the government defines the safety limit by considering the worst case scenario. That is, the position that has the highest absorption rate in the entire head, which has a size of an adult male's head. Here is radiation limit standard defined by several countries. The States and Canada both have a safe SAR level set to be 1.6 watt per kilogram, while the European nations and most countries in Asia specify the safe SAR level to be at most 2 watts per kilogram. And here on this page is the numeric definition and calculation of specific absorption rate. It is time derivative of incremental energy absorbed per incremental mass, or it can be expressed as rate of incremental energy absorbed by the relevant element of a given density phi. And for this basic form, it can be further broken down into the following forms. This form is related to the temperature elevation in the tissue. It can be expressed as SAR is equal to C times delta cavity over delta small t, where C is the specific head capacity, delta cavity is the rising temperature, and delta small t is the exposure duration. The next form is related to the electric field in the tissue. It can be expressed as SAR is equal to sigma times E squared over phi, where sigma is the conductivity of tissue, phi is the mass density of the tissue, and E is the root mean square electrical field strength. Of these two forms, electric field measurement is typically applied to evaluate the SAR of low power transmitters such as smartphone or cell phone. Now that we have the algorithm to compute the SAR level, we need the data needed by such algorithm. Here, this graph shows how a simulation typically performs under normal conditions. It is a mobile device, and this apparatus is going to hold a mobile device on the test, and it will adjust the tilting and angle between the phone and the phantom. The phantom is used to resemble a user's head. It is filled with a liquid that correlates the dielectric properties of human head tissues. The dielectric properties have been calculated taking into account the properties of human brain tissues and matching effects of other tissue layers such as skin and skull to provide a conservative overestimation. Then a robotic arm equipped with a probe is then to evaluate SAR measurement by setting up a reference point and scanning a specific area in the phantom. Oh, one thing that's worth noting is that the phone under testing is operating at 35 maximum power level, while in reality all the phones are operating in low power mode to prolong battery life. That means the actual value of your SAR phones is typically lower than what's labeled by the Federal Communication Commission. So please don't be alarmed if you find out your phone, such as Droid X, Motorola, or Nexus 1, has high value of SAR, because indeed they are not that high. They are not that high. Anyway, from the perspective of our project, the phone we choose, which is Google Nexus S, happens to have only 0.5 watts per kilogram, while the other candidate has the SAR of 1.17 watts per kilogram, which gives us legitimate argument as to why we choose Android 2.3 over iOS 4. Next, G is going to present more on the topic of electromagnetic prevention.
Hi, I'm G. I'll be talking about some preventive measures what we can take in our day-to-day life. First and the most important thing is children being a huge amount of market share in cell phones today. We have compared a 5-year-old child's brain, a 10-year-old, and an adult. It is easily seen that 75% of the brain of a 5-year-old child absorbs radiation, while that of a 10-year-old absorbs 50% and an adult absorbs 25%. So it is easily seen that children are at more risk and their exposure to cell phone radiation would be more than us adults. We should often start using headsets and speakerphones because that would limit the radiation that's absorbed by our brain, because our cell phone would be away from our brain. By using your phone only when you have good reception, because if your cell phone has low reception, then your phone is going to emit more power, because of which the radiation would increase. We should always keep the phone away from our body. It is recommended that phone should be away 6 inches even though when it's not in use. So keeping in pocket does increase the risk of infertility in males. Choosing texting over talking. The research says that texting emits way less radiation than talking on cell phone. So if your conversation just requires yes or no, it should be just done by texting rather than talking. There is in the market there are radiation shields available by which they say that they reduce radiation, but what they do is they decrease the call quality by which your cell phone tries to emit more radiation, and because of which it's more dangerous to us. To summarize, our group concludes that cell phone radiation is not harmful because it usually works at low power and doesn't have enough penetration power to the damaged brain tissues. But studies also say that prolonged use of cell phones does increase the risk of glioma tumor, that's a common brain tumor, and it is highly recommended that children shouldn't use cell phones as they have higher absorption rate than adults. We'll be up for any questions.
Questions from the class?
I had a question. You guys referenced, I guess, a bunch of studies relating to whether or not cell phones cause cancer, but I didn't really get whether there's actually is or is not conclusive study results that show that it actually does or doesn't. So what you said both.
They're not any conclusive, that they haven't taken any size whether it does, because it's a very long-term effect, and you can't predict, that cell phones are the only reason why it's causing it. So there have not been any studies which conclusively say yes, it does or it doesn't. But considering EM and considering how power and distance plays a key role, it's very highly unlikely that it does in a smaller time frame rather than a longer time frame. For example, you're exposed for it for years and years. It's very highly likely that increase your chance of having cancer by some percentage, but it's not like that was the only reason.
Okay, so that group that was proposing the warning labels didn't have like a test they were basing it on. They just were going on that. I guess.
Yep, because it's just increasing the probability of you having the cancer.
Okay.
I think we're forced to say prevention is the best cure. We don't know what the extreme long-term effects are. Just trying to limit use right now.
So I went to a forum on the Japanese disaster last week, and there's an expert in there who's talking about radiation, and he's been studying the effects on Japanese that have survived in Hiroshima and Nagasaki. And he claimed right away, he said radiation does not cause cancer. He's been studying the patients there for long periods of time. He says the fact is 1 in 3 of us in the audience would probably get cancer. We'd all get cancer if it wasn't for the fact that we usually win the race to death first before the cancer can get us. So
I think there's a slight issue, and I think as Sean pointed out, there's ionizing and non-ionizing radiation. The ionizing radiation is higher frequency and high energy, and actually is knocking off the outer electron, causes ions, and that is really what they're saying causes damage and cancer. And I will say, high doses of radiation will probably kill you well before the long-term effects of cancer, so maybe there's that correlation that don't see any studies with regard at least to ionizing radiation doesn't cause cancer. I didn't find that at all. I don't know if anybody else. It's interesting though.
Okay, well, I'm still scared. So. Anyway, I keep my cell phone in my pocket, but I've already had kids. So. All right, thank you.